in a very special way and seeing an opportunity that I think no one else has fully articulated. My own experience with Adam started because I was trying to do something that was almost impossible. And a good friend of mine said the only person in the world who could actually think about this is Adam. And Adam has just now introduced me to Javier, who is the CEO of Divirod. And you will come to know what that means in a few minutes. So thank you so much. Thank you all for being here, and thank you so much.
Thank you, Bruce. And of course, it's impossible to follow Bruce and BC in a public talk and a public function. So I'm going to try to get a slightly different style, which is not so clear and certainly not so designed. But I hope we'll be able to introduce a few ideas. One is about harmonics, and one is about orientation. So with harmonics, indigenous communities the world over listen to the stars. They know their environment, as we've seen from the first talk this morning and from some of the themes that Bruce was bringing up. So when Lawrence van der Post was working with the Bushmen of Kalahari, they were horrified that he couldn't hear the stars, that he couldn't engage with and talk to the environment around him. So harmonics are a force that's all around us, and that we can either listen to it or not. But orientation amongst indigenous peoples is equally important. You have to be able to orientate yourself in the environment you inhabit. And I think this map from Siberia, which is a stone engraving, is a completely extraordinary reference to how mankind constantly orientates their relationship to the world they inhabit. Really, the harmonics now are coming not from the stars, not from the natural world, but from the man-made world. So this is one of the most amazing websites. So Lowe Labs have a dynamic real-time tracker for satellites moving around the Earth and where they come from and who owns them. This is a still image, but you can zoom in, you can pick up any satellite and follow it. If you can do that to satellites, just think what you could do if we had the same relationship to, say, the water on the Earth, which is what Javier is going to talk about. So Bruce has done the introduction, so I can keep this bit very, very short. I founded Factum Foundation. There's a second part that's called Factum Arte. They work with artists, with contemporary artists from all over the world. But Factum Foundation really develops technologies to record cultural heritage and bring it to new audiences, which is really how Bruce and Missy and I came into the same orbit. So we record cultural heritage, and Javier Marti and his extraordinary, I'll do a very quick introduction of Javier. He used to work for the European Space Agency. He was mapping deep space. He then turned it around to look at the planet and realized that if we could have real-time mapping of water all over the planet, we would be in a different place. And so I met Javier with a project Factum Foundation runs in Venice, and we'll come to that in a second. But this is one of my favorite things about sketching, I think, Bruce, if we're going to do it like that. So on the right is the blue marble, the map of the Earth taken in 72, it's off the bottom of the picture. When this map first came out, it was this way up. When it was first published, it was the other way up, because NASA thought it would be rather difficult for people to understand the globe if south was at the top. So this is an inverted version of the normal map, but this is the orientation the photograph was taken. If you compare it to Al Idris's world map from 1150s, it's staggeringly similar. So the El Idrisi is a bit difficult to see, but I love the idea that a group of people, dominantly Arabic, working for Norman kings in Sicily, created what is possibly the first world map. And if you look at it, it has south at the top. When it's stretched out, it has Mecca in the center, it has the Red Sea and the Persian Gulf. What was then the most civilized part of the world is over here, is Spain and North Africa. So this map is a moment where art, science and technology came together in the 12th century. This is one of my favorite maps, which was done in the 1690s. And this was done by a man called Willem Gore. And it's the first visualization of what this planet would look like if there was no water. So this is the it's not a mouse-nibbled map. This is a map of the world with no water on the planet. So this is the lithosphere, the stone basis that we inhabit. But in terms of what Bruce was talking about, if you're designing a different world, you have to put people into a different world. And this was the 19-metre in diameter globe that was built in Leicester Square in London in 1853 with hydraulic lifting platforms that was the most visited site in the world. And as I arrived here last night, seeing the big wheel, which is great, but the big wheel is kind of 19th century fairground. This is 19th century mind. So you're on the inside of a globe. Imagine building this 100 meters in diameter and taking people around it and having dynamic projections so you can see what's happening all around us, all over the world at the same time. And it's totally possible. And what I hope Javier and I can get to by the end is something that's totally practical. So as a way of introducing Javier, there's two projects that focus entirely on water that Factum Foundation is involved in. One is in Venice. Well, as we know, Venice is sinking. This is one of the mantras that you hear. It's true. Venice is sinking 6 millimeters a year and has been for the last 300 years, maybe longer. It's largely due to the draining of the aquifers more than the rising of the sea, but it's a mixture of both. And what Factum did during COVID, which is how Javier and I first met, is we sent a team of people, because they were meant to be recording in Alula in Saudi Arabia, but I couldn't get them to Alula, so we sent them to Venice, where they were on an island and they could work sort of in quarantine. And during that time we recorded the whole of the island of San Giorgio. And I don't just mean with LIDAR, I mean we did it so that you could read at ×10 magnification all the letters. We were recording books and paintings, and then it's recording the surface of paintings. We recorded all the sculptures. But really we were developing a project about changing the way we see the world. So for me, this idea that north is at the top and south is at the top is something we have to get past. And this was a real project that sadly didn't happen. On this island in Venice, where we dreamt up a plan to build the lithosphere, a model of the world with no water in the oceans, at the size of a football pitch. And so this is the world from high-resolution data, but with the z-axis, the height, extended 100 times. And what we then proposed is you should pump the water of the lagoon into this swimming pool form until basically it reaches the level that it is now, which is going to happen any minute. So look, watch Florida. Florida's just appeared. And then you keep flooding it at equal speed, and suddenly the world changes very dramatically. Well, we went on flooding it until we flooded over the top of Mount Everest, and everyone said, but Adam, you can't do that because there's not enough water on the ocean. And I said, yes, but this is poetic. So we built it at a small scale and flooded it. But we built all the prototypes to build it at a big scale. While we were working in Venice, something slightly strange happened, which is this building, which was designed by Alvar Aalto, one of the great 20th century architects, and is made of concrete. But unlike most concrete buildings today, this is pushing concrete technology to the limit. It's absolutely amazing, the engineering. And it was built in 1931. And it sort of fell into the hands of Factum Foundation. And we're now transforming this into an exhibition space and a research centre. And this is really where I want to get to what Javier is doing. But effectively, Venice is sinking 6 millimetres a year. Oulu, in the middle of Finland, is rising 8 millimetres a year. Why? Because of what's called post-glacial rebound. As the ice melts, the land springs back. And that has really big implications. So you can see the epicenter is sort of in Sweden. Oulu is just above the letter 8 on the map. And as the land comes up, land rising has as many fundamental impacts on the world we inhabit as land sinking. If you look at this rather wonderful map from the 17th century, you can see all the rivers in Sweden, around Lapland and in Finland flow into the Gulf of Bothnia. And the dynamic relationship between land and sea really brings about something that I want to hand over to Javier. There's a mixture between science and fact and folklore. So it's cold a lot of the time up in the Arctic Circle. And the very famous sort of truism was that there were furry fish in Canada. I did this for Bruce. In Canada there were furry fish. There maybe are furry fish, but of course they don't exist. But this is not a trout. The furry fish is normally associated with trout. This is a furry pike. And the extraordinary fact is, so it's a cannibal fish. Pike is a freshwater fish, but pike now live in the Gulf of Bothnia. They now live in the sea because so much fresh water is flowing in, and the Baltic is a really unusual ecosystem that's more dependent on the wind direction than it is on the tide, because the tides only come in through a little bit by Copenhagen, by Denmark. And if the winds are not blowing properly, the Baltic becomes freshwater, effectively, the Gulf of Bothnia especially. So freshwater fish live in the Gulf of Bothnia. So the what if that Javier and I want to present today is what if you could record not only the things that Javier is going to talk about, water height in relation to land, wind speed, etc. But what if you could also record water temperature and water salinity, all using waste data from satellites?
Thank you, Adam. I don't know how to put it better, but let's see if I click here on the slideshow. Can I have the next one? We need the full presentation. Okay, this is putting in suspense. Okay, here it is. So, following up with Adam was talking about, we actually met some time ago during COVID, and I was listening to the radio, something that we don't do anymore. But I was thinking about water. Water is everywhere, and water essentially is covering the entire planet in many different forms and fashions. But water in running outside and in the free world is actually very little understood. We know how much we can have here, but if I do this, now tell me how much water is there. Is there enough technology to say, I can measure that water on the floor? No, I know when it's contained in pipes and in containers, but I don't have a clue when it's on the ground. So imagine on the planet, imagine on communities, imagine companies affected by this type of water emotion. So that's the essence. Water is beautiful, but water also has an impact. And I'm not going to put a doom and gloom paraphrasing Allison earlier today, but we're living with water risks. And we're living with water risks because water is essentially free to go wherever you it likes. And it affects everyone. It affects communities, affects corporations, affects the economy. The aftermath of all these water problems is tremendous. So if you think about ways to deal with this problem, the first thing that you realize is that we are living in the presence of water data scarcity. And this is actually quite central to what I do. So we're looking into building the Google Maps of water. And you think about, what is that? That's a real-time ground truth representation of where water is and how we can live with it and interact with it. So you're looking at the United States, and of course, it looks like everything is populated and covered with data points. But in fact, it's not. The more you zoom in, the more you see that the dots which are putting this beautiful map together are falling apart, are moving apart from each other. There is not enough understanding what happens between dots. And this is where solutions have to come, and solutions need to be come into place. So as we traverse the United States, you can see that the little dots is like just little dots that are not providing enough information for us to understand. Do we have enough understanding on how to live with water? So what can we do with this? So for me, as a technologist, I'm working in this intersection of technology and science for a long, long time, and did, quite frankly, quite a number of multi-billion-dollar projects which are looking into space and things which are not far from us. Now my efforts are being refocused into the planet, into the water space, because it's the only thing that we have tangible. If I look at the effects of climate change, everybody can live with a hotter environment or a colder environment. But I don't know, raise your hands if you can live underwater or without water. I don't think so, right? So for me, the missing element here in the whole climate discussion is how to deal with water, how to be anticipating to water. And we can only do it today with the technologies that we have at hand in a way that is comprehensive by bringing together two aspects of technology. One is the Internet of Things. So yes, sensors that need to capture water at many different places. We should be able to put a dot on the map anywhere we like, right? So if we are concerned about this pavilion, why should I put a sensing of water, south of Dubai? No, I have to put it here because this is what I'm concerned about. And the other part is bringing the power of data and artificial intelligence, data analytics. How can we manage a problem which is global, which is full scale, which is the tremendous magnitude of the water problem is essentially so large that can be comprehended properly if we don't put all the power of technology at service. And data and AI can do us a big favor. So this is essentially how we are moving ahead with this. So if you want to think about putting together all this technology at service, you have to think about bringing, first of all, standard ways of getting the data together. How can I measure in a very same manner in Venice, in Spain, in the United States, here in Dubai? How can we measure water in a constant way and in a very uniform way? And the other thing is essentially that we have to bring all this data into a place which is accessible, which is ready to be used, and we have the data at our fingertips. So when I'm talking about information, I like to give this example. So if data is not accessible, it does not exist. So today, you want to have it at your fingertips, and the only thing that is at your fingertips is your phone, right? So keep it open because we're going to have a need for you later. So if I have, starting with the IoT, with the Internet of Things, if I wanted to have a wish list for how can I measure globally My ideal wish list would be, I want to have something which is global, that can be of interest anywhere in the world. I want to have it standardized for the reasons I gave before. But also I wanted to have a real time. I mean, we're in the 21st century, come on. We need to have ground truth, we need to know, we need to measure, not model. We can measure, let's measure. And let's take care of some of the calibration and maintenance analysis that we don't have to deal with. And last but not least, I want everything to be very normalized, that same vertical datum. And for those who are not familiar with that, that means putting everything to the same reference. So the 0 for water is somewhere defined by the GOA of the world. And the data should be reflected to that, not the way that is today. That is so disparate and difficult to put together that, sometimes it's very difficult to compare. So for the audience, let me present you the power of GNSS-R. GNSS stands for Global Navigation Satellite System. So, and R stands for reflectometry, but I'm going to call it radar for short. If you think about this place at the moment, you don't see that. But if you were to see the signals coming down, you're now seeing that it's raining GPS signals everywhere. Navigation satellites provided by governments are constantly bombarding the Earth with signals. And this is where the magic begins. So we have already something that has been paid by governments. We don't have to build anything else. And take advantage of all these signals which are blasting the Earth as they come into the ground, the reflecting of the water, reflecting everything out of any surface, and come in and picked up by a sensor which is the size of, a poster. So this is in relation with the Harmonics. So what we see here in this picture is all these satellites are there as they're moving, they're actually moving across and producing reflections in front of our sensors. And those signals are free to use, and if no one is listening, the signals are gone and lost. So this is a very interesting representation because not only you have this dancing, this harmonic of movement, but out of all these reflections, we are able to capture very critical data on the Venice Lagoon and many other places that we're already working at. And this is exactly what is important to have in real time, so that if we have not only this data from Venice, but everywhere around the world, we're going to have the power of understanding and the power of doing a lot of things with data. But water is not only the oceans. If somebody thinks that the water can be compartmentalized, that's not true. Water is actually everywhere. It's in soil moisture, it's in the snow, it's in ice. There's precipitation. There is water levels in reservoirs, rivers, and lakes, and we have to account for all of it because water, as a beautiful thing that Adam was showed before, is all connected. You cannot separate it. You cannot put it down before it gets to the ocean and say, "Dear ocean, this is dear river." No, they're actually merged together, and we need to come up with things that provide us, the power of analytics. So when you capture all this information, you're starting unifying the data, you're starting being able to actually select locations, understand better, look at the impacts, look at the forecast, produce early warning systems, which are so much debated this way, but no one is daring to put it in place because there is no data. So this is real time. This is the first time I'm presenting. This is the Google Maps, or the sketch of the Google Maps of water. So what you're going to see now is a representation of the United States. We captured the rest of some of the places in Europe and in Australia. But what you see in this map is you're going to see a display over 1 year of data, which is not only these data points are actually a multitude of data points that have been brought together to make this visualization. And this visualization is going to show in purple what we call the water level index. So when there is more water than usual, and in yellow there will be less water than usual. So whenever somebody clicks play, you'll see how this is transmitted. So this is very interesting. As you can see, as it goes through the year, the water is not in the same place. It's not. We don't have enough water in certain places, and there's too much water in others. As you go through the month of March, you see that California was, receiving an excess of water with one of the hurricanes coming from there you go. And now in the springtime, you won't see that. You could have seen that. In the springtime, you see the ability of all the water that is coming from melting in the Rockies. So again, going back to the disparity of how much water is available, how much water data is available. If I select Boulder, Colorado, the time that I'm living in, this representation is giving you the distance to the water data points that we're collecting. There's no more than that. If we don't do anything, like if you're living in central Boulder, there is only a few handful of places of water collection, which is too far away to be meaningful to the citizens or to the corporations or whoever is interested in understanding that water is. So with that technology, which is this compact, we at Divirod, we are actually going to put millions of data points on the map to put together a proper image of the world. So, empowering data analytics, empowering early warning systems. That's what we do best, and this is where we are today. And why we do that? Not only because we want to make money. Somebody said this morning, what is the word? Adaptation is too long. I'm saying dollars. And dollars is what affects everybody, unfortunately. And not because we want to get dollars just for ourselves. We do this because everybody, at the end of the day, it affects everybody. It's ability. So if we empower people with information, adaptation rules, resiliency, everybody will win. Everybody will save money. Everybody will save lives, and everybody will be available to do something. So what can you do? You may be thinking, can I do something about this? As a person, as an individual, this is COP. So why not to think that if you put together the money that people are spending in coffee, just 100 people, every day going to Starbucks, back and forth, put it on a jar. With that money, you can make a change. You can actually go and put together a system that will provide a lot of information to you and to others. And with that, I would love to offer you a data gift, which is a vision. Hopefully it works. It's a vision of what's going on in Venice right now. So this is real-time data, and I'd love you to scan it, load it on your phones, because everybody has a phone, and tell me what you think.
So when Javier and I first started working together, it was at the beginning of the pandemic, so it was in 2020. But I think a lot of you can probably remember that in November of 2019, there was a flood in Venice, an acqua alta, that went up to 1 meter 87. So the critical level in Venice is 1 meter 30. There's been billions of dollars spent building the mosaic, building the barrier. And the barrier has been amazingly successful after a slightly delayed start. But what happened that day is the predictions were that the water would get to 129, 130. But it went to 187. That's nearly 60 centimeters out. And that's a critical measurement. What Javier said when we first talked was if they could have been monitoring real time the change in the wind, they would have realized that the water was being pushed in much faster and much more forcefully that caused that acqua alta that came with the corresponding damage both culturally and financially. The same would be true as we're putting monitors in Lowe to monitor not only the water height and the wind, but also if we can focus the next bit of research, the salinity and the temperature, which are critical things in Lowe and the other work that Javier is doing. And it is one of the things, we're talking relatively small amounts of money. So if every nation that came to COP28 put up $200,000 a year for the next 5 years, you'd have a whole network of sensors. Not complete, but it would start to cover the whole surface of the Earth. And it's this that we're trying to push now. So we'd love everyone here to lobby everyone they know, because real-time, 24/7 measurement of water, of the actions of water, of the height of water in relation to the land. And one of the things, as Danielle is here, but with Global Author, we're trying to now put sensors all the way along the coastline of Portugal and all the way around the Azores. I mean, so we're measuring water height, wind direction, wind speed, wave frequency, etc. Hopefully we can measure the temperature and the salinity. And with the right sensors on lighthouses, you could also be measuring lichen and lichen growth and other things. So once the sensors are placed, you can look at different things to be recorded. But if you've got real-time data of the coast of Portugal, real-time data of the Azores, and real-time data of the coastline of Maine, where there are sensors already, you'd have for the first time a dynamic model of both sides of the Atlantic and the center of the Atlantic, which would be a work of art. So I think it's this bridge between art, science, and technology, between designing a better world and actually doing it. So on I didn't want to read out my manifesto because I'm afraid you've heard most of it. But really, I'm very bored of talking. This is all about action, and it's totally doable if politicians decide to do it.
Yeah, and I would like to conclude with saying about action, somebody has to take the lead. And I'm sick and tired, let me speak very frankly and openly. Sorry. I'm going to say something very provocative, but I'm tired of waiting for governments to come together and do something which is meaningful and, advancing us. We need to take the stand, and we actually need to take the lead. And here we are, a very small company in Boulder, Colorado, taking the lead of creating the Google Maps of water. That takes a lot of bullish attitude and boldness. I want to change the world. I'm going to change the world. The world is going to be changed, and we're going to live better with water. Thank you very much.